What's up, guys, and welcome to this video on question 2 of the 2016 supplementary exam. It says it has to do with athletics training, but it's more about vectors, I would say. Vectors, forces, let's see. Yeah, basically that's about it. Okay, nice question. 24 marks, so let's get straight into it. Okay, so Simon is hanging at rest from a hoop which is attached to the ceiling by 2 ropes. The ropes make an angle of 50 degrees and 60 degrees as shown in the diagram. The tension in rope P is 500 newtons. Okay, the weight of Simon's not given. Okay, so I want to just add in here that this is also 60 degrees and this is also 50 degrees using alternate angles and maths. Okay, so question 2.1.1, define a vector. Okay, so a vector is a physical quantity that has both magnitude and direction. Okay, and for that definition, we get 2 marks. Okay, question 2.1.2, determine the magnitude of the horizontal component of the tension in rope P. Okay, before we do that, I'm going to draw myself a free body diagram. So we have rope P. Okay, and let me draw that less steep. So we have rope P, this angle 50 degrees, and we have rope R on a rope Q, and this angle of 60 degrees, and we have this person Simon, and he will have a weight component. Okay, so we want the horizontal component of the tension. Okay, so the horizontal component of P would be that component right there. So what we have is we have the force P was also given to us as 500 newtons. Okay, so P horizontal is equal to 500, and the horizontal component would be cos of 50 degrees. Okay, if we plug that into a calculator, we get P horizontal is equal to 321.39 newtons. And because it asks for magnitude, that would be the final answer. But if we wanted a direction, that would be left. Okay, and we get 2 marks for that. Calculate the magnitude of the tension in rope Q. Okay, so rope Q also has a horizontal component. Okay, that component there, and because the hoop is in equilibrium, the sum of the forces. Okay, so this is question, let me actually do it next to it. Question 2.1.3, the sum of the forces in the, let's say, this direction, the horizontal direction, is equal to 0 because we can say stationary, or because at rest. Okay, taking that into consideration, we can say P would be minus P horizontal. So we can say minus P horizontal plus Q horizontal is equal to 0. So Q horizontal is equal to P horizontal, which is equal to 321.39 newtons. Okay, but what do we want? Sorry about that. What do we actually want? We want the magnitude of the tension in rope Q. So we want Q. So we're looking for Q. So to find Q, we can say that Q horizontal is equal to Q cos of 60, which is equal to 321.39. The only unknown here is Q. So we can say that the magnitude of Q is equal to, if we plug this into our calculator, we get 642.79 newtons. Okay, and that would be the final answer. If you wanted a direction, it would be in whatever direction that is. Okay. Yeah. So we get ourselves 3 marks for that, and we only get about magnitude. Cool stuff. Determine Simon's mass. Okay, so to do this, 2.1.4, I'm going to say that the sum of the forces, let's say up as positive, is equal to 0, again because of the system being at rest. So then what I can say is that P, so now I care about this upward component, so P sine of 50 plus Q, once again upwards I'm taking as positive, and I care about this upwards component, Q sine of 60 minus the only downward force is his weight, is equal to 0. So we can say that weight equals P, which is 500 sine of 50, plus Q, which we calculated as 642.79 sine of 60. If we put that into a calculator, we get a weight of 939.69 newtons. Okay, but what does the question ask? We want Simon's mass. So mg is equal to 939.69. So mass times gravity, 9.8, is equal to 939.69. Okay, the only unknown in this equation is our mass, and so we can get a final answer as mass is equal to 95.89 and units of kilograms. And there we go. That's our final answer. And we get 5 marks for that. Quite generous, giving us 5 marks. I'd say so. Okay. Anyway, question 2.2. A sportsman is busy training and is sprinting a marked out pattern on a field. The diagram below shows the path taken by the sportsman. He starts the stopwatch at point W. The positions of all the points and the readings on the stopwatch are given in the table. Okay, so let's see. Okay, I'm going to put the times in black. So t equals 0, t equals 5, t equals 10, and t equals 25. And the positions I will put in pink or red or whatever color, let's say red. So I'm going to say this is 40. So at 0, s equals 0, s equals 40. Here I'm actually going to put the direction. So 40 north. Here we went 40 e. These are the coordinates. Okay. Okay, so 40. So this is 40 north and 40. What's that? East. And here we have 40 east still and 80 south. Okay. Okay, so that's what we've been given basically. Okay, so question 2.2.1. 2.2.1. Here we go. Define distance. Okay, so distance is the length of the path traveled. Okay, and we get 2 marks for that. Wow. Okay, question 2.2.2 says determine the sportsman's distance for the 25 seconds illustrated. Okay, so we want his distance. Okay, so distance is the length of the path traveled. Okay, so from W, so basically what we want to do is we want to say this is equal to the distance traveled from W to X plus the distance traveled from X to Y plus the distance traveled from Y to Z. Okay, so the distance from W to X is 40 meters plus the distance from X to Y is also 40 meters plus the distance from Y to Z is 80 meters, and so we get a total distance of, wait, I've missed one. Remember the distance traveled. Okay, so this distance here was 80 meters, and this distance here is 40 meters. So the distance from Y to Z is actually plus 80 plus 40 is 120 meters. So if we add that all up, we get a total distance equaling 4,200 meters. Okay, so remember these were the coordinates. Okay, cool stuff, and we get 2 marks for that. Okay, question 2.2.3, determine the displacement for the 25 seconds. Okay, so displacement. Okay, so the displacement, his displacement is going to be this. The sportsman's displacement is that. Okay, and so that triangle, if we look at that triangle, we have 40 there and 80 there, and that's a right angle. So we can use Pythagoras. So to get the displacement, we can say the displacement is equal to, using Pythagoras' theorem, it's the square root of 40 squared plus 80. See, it's equal to the square root of 40 squared plus 80 squared. Okay, and this gives us a displacement of 89,44 meters. Okay, but also remember that displacement has a direction associated because it is a vector. Okay, so we need to figure out what theta is. Okay, so tan theta would be equal to the opposite over the adjacent, which is equal to, what's that, opposite of 80, adjacent of 40. So if we put that into the calculator, the only unknown here is theta. So theta is equal to 64,43 degrees. So our total displacement, so the final answer is going to be, okay, we can say the final answer is 89,44 meters at an angle of 64,43 degrees. Let's see, this is south of east. Okay. Another way we could have said this is we could have also said it is clockwise, for the direction clockwise, 64.43 degrees clockwise from east, or something like that. Okay, so that's an alternative way of representing it, and we get 5 marks for that. Okay, so question 2.2.4, determine the average speed for the sportsman for the two. Okay, so average speed is just equal to the total distance divided by the total time. Okay, we already calculated the total distance as 200 meters over the total time, which was 25 seconds. And if we put this into our calculator, we get a value of 8 meters per second. And that is the final answer. Yeah, it is a vector. I mean, it is a scalar. Speed is a scalar, so we don't need a direction. Yeah, so that is that, and we get 24 marks for question 2. Quite nice. Okay, in the next question we will do, or in the next video rather, we will do question 3. Yeah, so I hope you guys found that useful. It was quite a nice, short, simple video. Let's see how long it took me. 15 minutes, let's say, explaining it for 24 marks. So nice. Okay, thanks for watching, guys, and I hope you found this useful.